Okay, today we're going to be working on Chapter 11, Lesson 5, dealing with square root functions. We've discussed, at least briefly, square root functions this year. They're just a different type of nonlinear function. Here we describe it, or define it a little bit. A square root function is a function whose rule contains a variable under a square root sign. Now it's important to understand that the variable is what has to be under the square root sign. So in our examples here, all of these contain variables underneath the square root sign. If we take a look at the non-examples, there you'll see no variables under the square root sign. Pay particular attention to the last example here. Talk about this a little bit. This right here is not the variable being under the square root sign. This is simply a coefficient. So if we think about the square root of 3, the square root of 3 is roughly 1.73. So really all this is the equation y equals 1.73x, which is clearly not a square root equation. It is in fact a linear equation. So if we look down here, we look at different equations and are asked to identify if these are square root functions. The first one obviously is not. The second one, do we have a variable inside of a square root? Yes, we do. So that is a square root function. The third one here, do we have a variable inside the square root? Yes, we do. The fourth one, again, pay attention here. Is that a square root function? No, the variable is not inside the square root, so this would be no. And then finally, here's where you have to be careful. If I solve this for y, I'd have to square both sides, so y is equal to, now if I FOIL that, I get x squared minus 4x plus 4. Is that a square root function? It is not. We know that as a quadratic. Okay, so now that we've identified them, let's take a look at some of the translations that can occur in square root functions. You'll remember that I said square root function is just a different type of non-linear function. Well, the other very famous type of nonlinear functions that we spent a lot of time on this year were quadratics. And if you remember, translations in quadratics, you have vertical shifts, you have vertical translation, which we have here, and you have horizontal translations. And the reason I compare this to quadratics is because you'll see that translations in square root functions are very, very similar to translations in quadratics as well. So if you first of all let's take a look at the vertical translations. Notice that the constant is being added or subtracted to the outside of the square root, and that's going to shift directly as it corresponds to that number. So for example, I'll try to match the colors here. This looks like purple. I'm adding 4, so I'm shifting this up 4. So I'm starting at 4, and then I'm continuing on to mirror exactly what the original function looked like. So this was the plus 4 here. Okay. Now the next one, I'm adding 2. So right here you can see us going up 2, starting at 0, 2. And nothing about the function is being changed except for the fact that it's being shifted up. And then finally we have minus 1. If I go down 1, everything otherwise is the same. Okay. Now, Horizontal translations are a little bit trickier, but they are very similar to that of quadratics. You'll notice these are all being added or subtracted inside of the square root function. And the only thing to remember here is that they are opposite. So what I mean by that, if we look down here at -1, notice this is shifted over to the right in the positive direction, 1 unit. Other than that, everything else is the same. Then we have being shifted over inside the parentheses +2. That's actually going to shift in a negative direction, which sometimes can be confusing. Negative direction 2 units. Other than that, the curve is the same. And finally, the same thing for +4. That will be shifted. I'll do it down here. That'll be shifted 4 units to the left. Otherwise, the curve is the same. The only other transformation that I would want you to consider would be a reflection, similar to that of a quadratic. And a quadratic, y equals x squared, would be a parabola facing up. Y equals -x squared would be a parabola opening down. Well, let's see what this looks like for a square root function. I'm going to flip over to Desmos here. Here you can see I have in the red curve, I have graphed y equals the square root of x. And you can see that's a curve that's existing above the x-axis. Well, if I change that, or if I also graph y equals negative square root of x. Notice I'm not taking the square root of -x, it's negative square root of x. You'll see that that, in fact, flips. Think of this as flipping down under the curve. Okay? It reflects about the x-axis. That would be our only other transformation that I would want to show you in regards to square root functions. The rest of the lesson is actually more of a discover lesson. You'll be using Desmos, and you'll be looking at the domain and range of your sketches. One thing to consider about square root functions, and I'll use these graphs here, your domains and your ranges are going to be infinite, but only in one direction. So you'll always have a clear starting point because you can't take square roots of negative numbers. Usually that starting point is either going to be 0 for the y-axis or 0 for the x-axis. And then you're going to go on infinitely in one direction, both vertically and horizontally. So keep that in mind. I think you have everything you need to be successful in today's lesson. Thank you for listening.